Direct variation. What is it? How do we use it? And more importantly, how do I solve my homework problems with it? So, to begin with, direct variation. You're going to see something like y equals k times x. Direct variation just means that y and x are always going to have a certain ratio, and that ratio is k, whether it's 5 times x equals y, 12 times x. So no matter what numbers I plug in for x and y, this k will maintain a certain balance. So let's kind of work through an example. It'll be a little bit easier to see how it works out. So in this case, I'm going to say my x stands for gas and my y stands for miles. And we're going to find out if there's a constant direct variation between these two. So first thing I'm going to do is I'm going to try and find out what the k is. So I'm just going to take 30, plug that in for y. I don't know k, I don't know the direct variation, but I do know that there's 2 for x. Now, if I want to get k by itself to solve it, I have to divide by 2 to get rid of multiplication of 2, right? So I'll just put divide by 2, and on this side I have to do the same thing, divided by 2. 2 times 2 divided by 2 is just going to be 1. Those are going to cancel out. All I'm going to have left on that side is k. 30 divided by 2 is going to be 15. So now we know that there's this 15. So let's look back at this original formula up here. Y equals k times x. If I plug these things in, 2 times 15, 2 times 15 is 30. Okay, that does give me my y. 5 from right here, and 15, 5 times 15 is going to give me 75. And 8 times 15 would give me 120. So I would say yes, there's direct variation. The important thing here, we found that this k stands for 15. This direct variation is 15. Then we check, make sure that it works every single time. Show its direct variation, it's always the same ratio. Now you're still saying, I don't even know what this k is. What does this mean? Let's look at this problem. We want to find out how far we're going to go, how many miles we can drive. We know how much gas we're going to use, x. This direct variation, you know how much gas we have, we're going to find out how far we can go. The direct variation is actually just going to be our miles per gallon. We have 15 miles per gallon. If we have 2 gallons of gas, we're going to go 30 miles. If we have 5 gallons of gas and we get 15 miles per gallon, we're going to go 75 miles. So when you're trying to figure out if you're supposed to figure out what the direct variation represents, just look at your problem, maybe substitute your words in for the variables. You know, here you can put in miles, here you can put it in gas. You just got to kind of try and read it out until it makes sense to you. So let's do another example. Here we have one. A fruit punch recipe requires 1.6 cups of sugar for 8 servings. It requires 2.4 cups of sugar for 12 servings. How much sugar do you need to make 30 servings? Now, for this one, I'm going to set up a little chart like I did last time. I'm going to say that x equals sugar and y equals servings. So how much sugar we use will tell us how many servings we can make. So let me set up a nice little chart here. I'm going to put x on top, y on the bottom. Now the first one they give us, they tell us that 1.6 cups of sugar is going to be our x. 1.6. That's going to allow us to make 8 servings. Okay. Next they tell us 2.4 cups. We'll make 12 servings. Last, how much sugar do we need to make 30 servings? This we want to find out. Now we have this little chart set up, and we know that there's a direct variation. We just have to figure out what it is. We want to find out how much sugar we need to make 30 servings. So remember, we're going to have that y equals k times x. So let's plug these numbers in and figure out what x is again. Let's start with the first pair, the smallest numbers. We're going to plug in 8 for our y. Again, y equals 8. We're just taking it from right up here. We're going to get 1.6 for x. It's 1.6 times x. Oh, I'm sorry. 1.6 times k. I put 1.6 in for x. Again, x is 1.6. That's where I got the 1.6. So that's 1.6 times k. We don't know what k is yet. Now, we need to find out what that 8 is going to be. We have k times 1.6. How are we going to get there? Well, to undo multiplication, we have to divide. If you want to get rid of 1.6 to isolate the k, we have to divide by 1.6. That's going to leave us with just k. Again, we do something to one side of the equation, we have to do it to the other. 1.6. Now, 8 divided by 1.6. If you guys can use a calculator, that's great. Or, if you don't have a calculator, you're going to have to use the long way of doing this. But it's not the end of the world, right? What we're going to find out is that it's going to become 5. If we take 8 divided by 1.6, we're going to get 5. So our k is 5. Well, does that work? 5 times 2.4. Let's double check that. Again, 5 times 2.4, we'd get a 0. We'd carry a 2. 5 times 2 is 10 plus 2 would be 12. We have to move that decimal back over. Okay, that would work. How does this help us? We found k. Does that mean our answer is 5 here? No. Remember, we're looking for x. So if we set this up again, y equals k times x. Now we want to know what x is in this case. We know y is going to be 30. Let's plug that in. We know k is going to be 5. From right down here. And x is what we want to find out. Multiplication of 5 to get rid of that. We divide by 5. Do it to one side, do it to the other. Voila! We need 6 cups of sugar to make 30 servings of fruit punch. And that would be your answer. X equals 6. 6 cups of sugar. And that's how you can apply direct variation.